All right. And so today, today is going to be a fun one. Like I said, I think I said last time even, is that we're going into unsupervised learning, but I really like the clustering algorithms. I think they're very interesting on what you can do without basically having any labels. And that's going to be the big part of unsupervised learning. Is essentially, if we don't have a label, we don't know essentially what this is going to be. There are cases of something called semi-supervised learning, where basically you do have some idea of the labels, but there's a lot of them that just don't. I'm not going to go too much into that today, but it is in the curriculum. There's another aspect to kind of go into this part. But let me go ahead and start sharing my screen and, oops. Okay, there we go. So let me share my screen. And I will say, if you have done, I say this almost like every time now, if you have like forked the repo for the Flatiron resources I put on GitHub, note that I have drastically like modified this one. I try to make it a little more cleaner and stuff like that. It was an old notebook that I had put together, or a couple notebooks before. So I try to make it a little cleaner to like what we're talking about today. So just know it's a little bit different from if you have the old version. Okay, cool. So kind of like going right into it is that our first introduction to, the curriculum kind of talks about, is our first introduction to a clustering algorithm is something called k-means. And so one thing I want to kind of take a second for before we hop into a k-means algorithm, and then we'll see a couple other ones too. But what clustering is. So I mentioned before, both a PCA is an unsupervised learning technique, or it can be used as an unsupervised learning technique to basically do classification when you really don't know what the labels are. And that's where the key part of unsupervised, meaning there's no labels. There's nothing for you to really make sure that you have it right. So I think that's kind of like the idea. I can almost think of like models as almost like children. It's kind of like when we say it, unsupervised learning, it's like they don't have anyone to tell them what's right and what's wrong. They have to kind of figure it out from themselves. So here's just sklearn's, like section on like clustering. And note that there's a whole bunch of different ones. One that actually, we'll talk about k-means, and then next we'll talk about hierarchical I can't ever say that, agglomerative clustering. I'll just use it called hierarchical clustering because that's already hard enough for me to say. And then there's actually one I'll talk about today that's not in the curriculum called dbScan. And if we don't have time today, maybe I'll save it for like, another time. But another important aspect. But the idea here is that we have some data, right? So we have a bunch of features essentially. And let me go ahead and realize my thing's a little smaller than usual. There we go. Okay. So this is going to be basically like our clustering basically takes the idea of that when something is near another point, they're a similar, like they should be part of a similar group. So if you think back on like k nearest neighbors, that's the same idea that we were using. We're saying, hey, if something's close to it, then we should use that closeness to be like, hey, those things are probably similar to each other. Makes sense? Okay. And I'm just gonna mute you, Adam, real quick. It's all right. But you got questions, just unmute. But anyway, that's just kind of the idea of clustering, what's going on here. So kind of before we hop right into it, just kind of a knowledge check to think like, what situations would clustering be useful in? And if you read the curriculum, you might actually have seen a couple of reasons why you do this. But when might clustering be like particularly useful? Again, where we don't have really a label for the data set. Anyone got an idea? Okay, I'll go right into it then. So one example of this would be classically is marketing. Is that, you might have a group of people, you might actually know a lot about the people like through surveys, or, however you like have this set of people, and you want to basically say, oh, I want to give a certain, advertisement or a certain, deal to these groups of people because I know that will reach out to them. But I don't really know how to classify and group them together. Now, we can classically try to like do this, like, oh, well, males who are this age range who own a puppy like are likely to do these kind of things. But it would be nice to basically automate this process, especially since as we kind of like group them up and together, it's easier to kind of like really sell it to like a very specific set of people. So clustering can be really useful to identify those groups that are most closely together. And again, the whole concept of clustering is that if you have a certain number of features, people, or I shouldn't say people, but basically data points that are close together are very similar to each other. Okay. So that's kind of like an overview, like what clustering really is and what we're trying to achieve or how we're able to achieve it. Okay. So k-means, or yeah, k-means algorithm. So this is pretty, let's see here. I want to make sure I did this right. Okay, so I'm actually going to show you what this looks like in a second, but just kind of going over through basically the idea is that we have a bunch of data points, kind of similar to like how all of this data points over here, you can see like how they're differently structured. And we're trying to figure out where they belong to. So one key part is basically say, hey, we gotta figure out how many groups do we think there are. Do we think there are 2 groups? Do we think there are 3 groups? Do we think there are 5 groups? We have to determine basically this k part. So k means squared, right? But once we figure out, like, at least we try to say, okay, we think there are this many clusters, then we initiate our centers. Now, note that I put random centers. This isn't always true, but the centers are gonna turn out to be very, very important. And essentially we're gonna say, if we have 4 different groups, we're gonna have 4 different centers. And we basically place them somewhere in the data set. Think of like the vector space and say, okay, what are we gonna do with these guys? And what we do is we're gonna iteratively go over this over and over again. And I'm gonna show this, and it's gonna make a lot more sense when we do this visually. But essentially we're gonna say, hey, where's the, from this little center, what are the points that are close by? And basically we're gonna say, okay, those points that are close by to just that center point versus other center points, that's gonna be one group. And then we're going to adjust our center to move closer, so to minimize the distance to that average group. And essentially we keep doing that, where essentially we do an assignment, determine which points are closest, and then optimize, move the centers to minimize the total distance of the points that we identified. Okay. So I actually find this this visualization from this person, their blog, really great for demonstrating k-means. And it actually writes a lot about k-means algorithm and stuff like this. So feel free to, like, read this through. I think it does a great job of explaining, disadvantages and stuff like this. But we're gonna go from here. So note that this is just a little simulation. So I'm just gonna choose it randomly. So that means, actually I'm gonna restart. I'm gonna choose the centers. So I'm gonna choose where we put those points. And we're gonna start off with a Gaussian mixture. So basically just random. And you can clearly see how many groups there are. There should be 3 groups, right? Like that just makes sense. So let's just pretend I already know there's gonna be 3 groups. So I'm gonna put my points, let's say like right here, and right here. And essentially, like I'm choosing it right now. We'll see what this looks like when we do it randomly or otherwise. But you'll see who's like, okay, these are more or less in the right spot. So what happens on the first step is that, okay, we have our centers, our centroids, and we're gonna have to go step forward. So we're gonna step forward, and this is going to assign each of those points with the centroid. So it says, oh, these are all blue, these are all green, these are all red. And then what we'll do, we'll update the centroid, say, okay, we're gonna move the blue so it minimizes the overall distance. So imagine if I like had blue way over here, it would want to go closer to the center. So in this case, you'll see that most of them are pretty much in the center of the groups, but you'll see them kind of adjust a little bit. So if I click update here, you can see them kind of fluctuate a little bit. And you're like, cool. Then what would happen, we reassign any new points and then update again. In this case, you can see we're pretty much done. So that was kind of simple, right? But let's say we go back to doing that same Gaussian mixture, well, a different Gaussian mixture. And let's say I put like one red right here, and then I put the blue like over here, right? And then we put something like green like right here. Okay, so we can already see like it's kind of already mixing up, but these red points are gonna be really similar to each other. So we're gonna only use 3 of them. I click go, and you can see here, only these ones are the closest ones to the blue, right? Everything else like on this side is closest to red. So it's gonna be identified as red. And this is gonna be green. So you might think like, oh man, like our thing's completely broken, it's not gonna do it. But what we're gonna do now is we're gonna move the blue one, the red one, and the green one into the spot that's gonna minimize that distance. So you can imagine, like I like think of like the average like distance. I'm gonna move this blue one essentially closer to right here. This green one's gonna move closer right here. And where would you guys say the red one would move? Remember, it's gonna be for all the red points.
Probably about the middle of the page.
Yeah, probably middle, maybe like a little bit on this, like still kind of
Yeah.
higher up because maybe there's more over here, but probably about middle, right? So if I do this, update centroids, there we go. You can kind of see that, right? So about middle, and you can see that these points are still red, right? See, like those are original points. So now what we do is, okay, we move the centroids. Now we're going to reassign the points again. And we can see already, there are gonna be some points that are gonna be relabeled, right? So these are all gonna be blue again. These are all gonna be green. And then these will still be all red. And there we go. And so now we can see when we update the blue, blue's gonna scoot over to the side. green's going to move off to the left a little bit, and red's going to move kind of upward here, right? So red's going to move back up on this case, and we do this, we can see we pretty much have figured out our centroids. We might do another round right here, so to reassign the points. There's nothing to change. It might fluctuate just a little bit, but my guess is not, since they pretty much found it. So you can see, pretty much done. And what's really cool is that we can actually do this randomly. So before, I actually chose which points, but I can just say, okay, 3 points, and just go ahead and, oh, that's kind of random. I'm going to do something else. It just happened to be by chance. Oh, maybe, okay, there we go. This is something more reasonable. So this is like oh wait, like, is this going to work out, right? Because you can see there's an issue. So if I go and proceed it forward, we can see which parts are marked over. We can see the red one's going to kind of push over here. This blue one's got a couple right here, so it's going to move a little bit downward, but not too far, right? Because most of the points are up here. So we update the centroids, and we can see here, okay, look, we have it all moved over. And we reassign them, we update them again, and you can see basically it ends up the same spot, which is really awesome. Okay, so this is essentially how k-means works. Note that I showed you kind of like one of the most optimal parts. What do you think would happen if I added same Gaussian mixture, right? There's 3 points. So I added 3 before, right? So let's try if I added 4. Okay, what do we think would happen in this situation? Anyone got a guess? Because in this case, we're kind of like, you're still 3 groups, right? But there's definitely going to be something weird about at least one of these 4 points. Something's not going to work out properly. So what you can see here is if we go ahead and proceed this forward, we can already see this is green, yellow, and this is going to be red and blue. And so these are probably going to be marked as a separate group, but this red and blue is going to essentially fight it out a little bit. So if we go ahead and check that out and just kind of iteratively go through it, you can kind of see red and blue as I kind of go through. It kind of found a balance right here, but it kind of made them into separate points. So we can already see is that the biggest issue here is going to make sure you have enough centroids for the actual groups. Note that if I do something like randomly, I'm trying to think of a good one. Let's say example A. No. All right. So if I do something like uniform points, would you guys say there's a group in these parts? Probably not. I mean, maybe you could maybe find some patterns, but I would say it's more random noise, right? So if you had some centroids in here, it's gonna try its best to figure those points out, but it's not really going to be able to figure out the best thing. This doesn't really make sense to be this being a group versus this being a group. Okay, so we can already see some disadvantages for k-means, but that's the basic idea of how the steps of k-means works. Any questions on just like how this process goes through between the Gaussian mixture and having these like each of the steps, the iteration part, what we do, the assignment, and then updating the centroids? Sound pretty good? Okay, I'll take silence as a yes. Understandable? Okay, cool. All right, so once you know that, you can see that's relatively easy, right, to understand. Like there wasn't anything too complicated in this case. The most, like you can see the hardest part probably is just having those points actually, those points right here being assigned randomly. So you can kind of see some strangeness going on. And we'll talk about that for advantages and disadvantages. Okay, so one quick thing is that usually you don't actually know if there are multiple groups. And note that even though we're showing, this is showing in 2 dimensions, k-means can be done in multiple dimensions. So we can have many features where essentially we have, like instead of just 2 features, we have 3, 4, 5, 6, 100 features. So it's not as simple as just looking at it and say, oh, well, there's clearly 3 groups or whatnot, right? We need to have the algorithm decide for us. So the thing is that it doesn't really know. So the way you can do some evaluation here is determining this k. Just like if you guys remember back when we did k nearest neighbors, what was something that we did? Do you guys remember? How did we determine what k was? How many, I mean, k nearest neighbors, it's not exactly the same, but how did we determine k in k nearest? You recall? No, been a while. So basically it comes down to, we just kept trying every time. We just adjusted k and see what worked well. That's essentially what we're going to do with k-means. Essentially we say, okay, let's start off with 2 clusters or 3 clusters or whatever seems reasonable, and we increase it across that point. And the idea, and this is coming from the curriculum itself, is basically we're building an elbow plot. So if you guys remember back in I'm actually going to pull this up since we learned it, right? K nearest neighbors. There you go. Remember this elbow plot? Look familiar? Yeah. So you can see like basically we're saying, okay, what's going to minimize this error? And we're going to do something very similar with k-means, where essentially we're building this elbow plot here. And essentially when the distance, like it says on the curriculum here, number from which the sum squared distances, that's our error, right? So like the smallest distances, it starts to reduce slower. Then we're saying, okay, like there's not really much benefit for adding more clusters. And hopefully that kind of makes sense if I had like all these clusters, right? Like the distances aren't really changing by that much, right? So you can kind of see here is that really the distances are about the same. They're not really decreasing that much versus if I restarted and had it with just one centroid, we can already see, let's add 2 centroids. We can see here that this is going to improve drastically and then it's going to stop right here. But if I add another centroid, pretending we're starting from the beginning, this would hopefully, well, I got into this weird situation actually. This is not ideal, but ideally this would start moving over here and we would start getting, what's it called? Lower errors, okay? So one key part is that we want, essentially what number of clusters are, is like higher complexity, if that makes sense. Like the more complexity we get, the lower our error is. But what's the problem I mentioned before with higher complexity? It starts with an O. Like what's the bad thing?
Overfitting?
Overfitting, perfect, right? So overfitting is going to be a huge issue in that sense of as we get higher and higher complexity, we're going to be closer and closer to the overfitting. So that's essentially what we're trying to do for finding the first one that really doesn't adjust that error very much. Okay. Cool. Any questions? You guys feeling pretty good? Yeah. Okay. All right. If there's anything, come up now. So this is when we start finding some issues. And so we'll talk about this in our next little notebook over here. But I kind of want to show a little bit that graphic again, is you can see that each of these columns are different algorithms. And you can see already is that depending on what the algorithm is, you can see how it performs. Now you can see right here in this second to bottom row, all the algorithms do pretty well when they're like little blobs, essentially. When they're all separate blobs, it's pretty obvious the algorithm does a good job. But we can see like something, for example, the very last one. The last one basically is just all random uniform, points. It doesn't really make sense to have a different, what's it called, like different groups in this case, right? And you can see here, this on the very first column is actually k-means right here. And you can see k-means is trying to figure out, oh yeah, these are the different groups. But in reality, this doesn't really make much sense. And you can see also a few issues over here where it's not going to do the greatest job compared to, we haven't talked about any of these ones, but you can see already some of these other algorithms are going to do better at identifying what those different groups really should be. Okay, cool. So before I move on to issues though, everyone's pretty good with understanding how k-means works? Okay, all right, yeah. Main thing to remember, just take from it, is that essentially we put all those different points, we see what's the closest to it, we assign those points to the different group, and then we move our centroid closer to the rest of those points, and then we try the process all over again. Okay, so this goes into our issues, right?